What's going on, everybody? Welcome back to my YouTube channel. Now look at this nice and beautiful Olympiad question we have here on the board that we're going to be solving together. And the question says x to the power of 6 is equal to x minus 1 raised to power 6. And we are to look for the value of x. So how are we going to go about this? So I'm going to be writing the question here, which is x to power 6 equal to, now I have x minus 1 raised to power 6. Are you seeing that? Now, the first thing we're going to do when we are faced with a question like this is to move what we have on the right to the left-hand side. So let's do that real quick. So we have x to power 6. When I move this to the left-hand side, it becomes negative. X minus 1 to power 6. Are you seeing that? So equal to, now nothing is on the right hand side anymore, so I'm going to be putting 0 there. Now this can be expressed like x to power 3 or raised to power 2. This one here can be expressed like this. Why? Because from the laws of indices, whenever I have a base raised to a power, maybe m, and this is raised to another power of n, it means that the powers are multiplying, which means it can be written like this: a to the power of m times n. So which means that these two powers are multiplying. 3 times 2 gives you 6. So this is validated. So let's write minus. I'm going to be expressing this the same way by writing x minus 1 to the power of 3. Now I'm going to be raising that to power 2. So when these two powers multiply, I'm going to be having 6 as well. So equal to 0. Now pay attention to what we have on the bracket. Now what I have on this bracket is raised to power 2. And what I have on this other bracket is also raised to power 2. That means I have difference of 2 squares. And how do we express difference of 2 squares? Difference of 2 squares can be expressed as, for example, I have m squared minus n squared, which is the difference of 2 squares. It can be written as, in a bracket, m minus n and m plus n. Are you seeing that? Very good. So let's express what we have here like this. That means this should be my m, which is what I have on this bracket should be my m. And what I have on this other bracket can be my n. So let's express what I have here like this. So I'm going to be opening a bracket. So m, remember m is what I have on this bracket, which is x to power 3. Are you seeing that? Very good. Minus n. So minus n. What is n? N is what I have on this bracket. Look at it here. So what I have there is x minus 1 to power 3. So that is our n. So I'm going to be closing the bracket, open another bracket, and write your m. So it's going to be the same thing. The only difference is this plus here. Are you seeing that? So I'm going to be putting plus. So I write x to power 3, which is my m, but this sign will be plus on this other bracket. So n is x minus 1 to power 3. Now close your bracket. So equal to 0. Now, whenever we have an expression that is equated to 0, like this, maybe I have a factor multiplying another factor and it is equated to 0. That means as long as what I have on the right hand side is 0, I can equate each of the factors to the 0. That means I can write it like this. What I have on this factor is x to power 3 minus x minus 1 to power 3 can be equated to 0. Or what I have here, which is this other factor, which is x to power 3 plus x minus 1 to power 3 can also be equated to 0. So I have two equations to solve here. I have this to solve and I also have this to solve. So I'm going to be solving them one by one. So I'll be taking this one as case 1. So let me take this as case 1. So for case 1, I have x to power 3 minus x minus 1 to power 3 equal to 0. Now, take a good look at what we have here. This is like writing m to the power 3 minus n to the power 3, which is difference of 2 cubes. So this is the difference of 2 cubes. And how do we express difference of 2 cubes? This can be expressed as, open a bracket and write m minus n. Then in another bracket, we write m squared plus n squared plus mn. That's it. So this is how to express difference of 2 cubes. Let's continue. All right. So now it goes to show that this is my m and this is my what? N. So let's express this like this. So let's open a bracket. M, what is my m? My m is this x here. So write the x minus n. So minus, what is n? N is what I have here, which is x minus 1. So I'm going to be closing the bracket. Now open another bracket. M squared, my m is x. So I'm going to be squaring that, plus n. N is what I have as x minus 1. So I'm going to be squaring it as well, plus mn. My m is x and my n is this, which is x minus 1. So close the bracket, equal to 0. Now let's simplify this. So what I'm going to do here is to use this minus to open up the bracket. So I have x. When this minus open up the bracket, I'm going to be having minus x. So minus times minus gives you what? Plus 1. So this is what I have on this bracket. So now on this other bracket, let us simplify. So I have s squared plus, now we need to expand this. I'm going to be showing you a good trick that you're going to be using to expand this in no time. So whenever I have a value like this raised to a power of 2, please, the power must be 2. Anything more than 2, this trick cannot work for it. So the power must be 2. Whenever I have a polynomial raised to power 2, all I have to do is to take the first item, x, raise it to the power, so x to power 2. Now multiply everything, like 2 times s times minus 1. You see that? 2 times s times minus 1 gives you minus 2x. Now the last item, which is negative 1, is also going to be raised to power 2. So negative 1 to power 2 gives you plus 1. So we have been able to expand this. Plus, now let's open this bracket. So s times s gives what? S squared minus s times 1 gives x. So that is it, equal to 0. Now notice what we have here. X minus x is gone, leaving behind 1 here. Now open a bracket. Now let's add like terms. S squared plus x squared plus s squared gives you what? 3s squared. Very good. Now I have negative 2s, negative s. So negative 2s, negative s gives negative 3x. Now what is remaining? I have plus 1 remaining. So I'm going to be writing plus 1 here. Close your brackets and equate that to 0. Very good. So 1 times everything I have here is going to give me the same thing. 3s squared minus 3x plus 1 equal to 0. So I am left with a quadratic equation to solve. And when you take a good look at this quadratic equation, it cannot be factorized. So since it cannot be factorized, we're going to be using the general formula. That means I will be taking this first coefficient of s squared as 3, then b will be equal to negative 3, and c is equal to what? 1. So what is the general formula? So since I'm looking for x, I'm going to be writing x equal to negative b plus or minus the square root of b squared minus 4ac. Now divide by 2a. So let's substitute. So I'm going to be having x equal to negative b. What is b? B is negative 3. So I'm going to be putting negative 3 there, plus or minus square root b is -3. So I'm going to be squaring that. Minus 4 times a. A is what? 3. Times c. C is what? C is 1. That's it. C is 1. And now all over 2 times a. And a is what? 3, which is 2 times 3. So this gives us x to be equal to minus times minus gives you plus. So this is 3 plus or minus square root of -3 squared gives you what? 9. Very good. Minus 4 times 3 times 1 is what? 12. There you have it. So now all over 2 times 3 is 6. So simplifying further, I'm going to be having x to be equal to 3 plus or minus the square root of 9 minus 12 is going to give me -3. Now all over 6. So let's simplify what I have here. So x will be equal to 3 plus or minus. Since I have negative, I can split it into -1 times 3. Are you seeing that? Very good. So all over 6. So this gives x to be equal to 3 plus or minus. So I'm going to be going with this first. So this is a square root of 3. So let's write a square root of 3. Now, -1. What is the square root of -1? A square root of -1 gives I. Are you seeing that? Gives I. So the square root of -1 is I. So let's put the I there. Very good. Now divide by 6. Now we have the values for s. And in order to do that is to separate these plus and minus. So s is going to be equal to 3 over 6. Let's go with the plus first. Plus the square root of 3i, square root of 3i over what? 6. So this is one value for s. Now let's get the other value for s. So s, let me say or s, let's go with the negative, with 3 over 6. Very good. Minus, this time, the square root of 3 over 6i. Don't forget to put your I. But I cannot stop here because 3 can actually go into 6. So let's break this one down so we don't leave our answer like this. So 3 here is what? 1. 3 here is what? 2. So x is going to be 1 over 2 plus the square root of 3i over 6. Or it's going to be, this is also the same thing. 3 here 1, 3 here what? 2. So I have 1 over 2 minus the square root of 3i over 6. So that is our case 1. So we're going to be solving our case 2. And what is it? Very good. So this is our case 2 here. So I'm going to be taking this one to solve as case 2. Remember, we did this as case 1. So let's do this other one as case 2. Let's get through it. Okay, very good. So this is our case 2. Let me write it here, case 2. So now watch. This is like writing m to power 3 plus n to power 3. And m to power 3 plus n to power 3 is sum of two cubes, which can be expressed as, open a bracket, write m plus n. Now open another bracket and write m squared plus n squared minus mn. You can see that the only difference between this and that is not that much. Now, let's go. That means my m would be this x here, and my n would be x minus 1. That's it. So let's express this sum of two cubes like this. So open a bracket. Now I have m plus m. M is our x plus n. N is what I have here, which is x minus 1. So we have to close that bracket. Now open another bracket. M squared. M is what? X. So we're going to be squaring that. Plus n. What is n? This is our n, which is x minus 1 squared. Are you seeing that? Minus m. M is x. Then n is what? X minus 1. Very good. So we are doing well. Very good. Very good. So let's open up this bracket. So I'm going to be having x plus x minus, because plus times minus is still minus, right? 1. Very good. So I have this on this bracket. Now open up the other bracket. This is s squared plus, now you remember that trick we did, as long as it is a power of 2. So raise the first item here to power 2, so x to power 2, multiply everything, so 2 times x times minus 1 gives you minus 2x. Very good. Now the last item, which is minus 1, we have to raise that to power 2. So minus 1 to power 2 gives you plus 1. Very good. Now let's open up this bracket. So minus x times s gives you minus s squared. So minus times minus is plus, x times 1 is x. There you have it, equal to 0. So let's simplify further. So this is going to give us x plus x is what? 2x, right? So 2x minus 1 in a bracket. Then in this other bracket, we're going to be having s squared plus s squared is 2x minus x squared is s squared. So we have only s squared remaining like this. Now, what do we have next? This is minus 2s plus s. Minus 2s plus s is going to give you what? It's going to give you minus x. Are you seeing that? Very good. Plus 1. So put your plus 1 there, equal to 0. Now we have something like this again. We have a factor and another factor equal to 0. And remember what I said? When we have two factors that are equated to 0, even more than 2, as long as it is equated to 0, we can take each of the factors and equate them to 0. So this is going to be 2x minus 1, which is this factor here, will be equated to 0, or this other factor, which is s squared minus x plus 1, will also be equated to 0. So let's take this first one first. So this is 2x minus 1 equal to 0. When we collect like terms, by moving this negative 1 to the right-hand side, I'm going to be having 2s. As negative 1 crosses to the right-hand side, it becomes plus 1. So s here will be equal to 1 over 2. Very good. Very good. So now let's go with this other one. Let's go with this other one. I'm going to be turning to the next slide so I have enough space to solve this. Very good. So when looking at this, you see that it cannot be factorized. And since it cannot be factorized, what do? We use the general formula, which is, we're going to be saying a is equal to the coefficient we have here, the coefficient of s squared, and that is 1. B, the coefficient of x is negative 1, so I'm going to be writing negative 1 there. Then c is going to be plus 1, which is positive. So since I'm looking for s, the general formula goes to say x equal to negative b plus or minus square root of b squared minus 4ac. Now divide by 2a. So x is going to be equal to, let's substitute, minus b is minus 1, so I'm going to be putting minus 1 here, plus or minus the square root of b squared. Remember, b is minus 1. So I'm going to be putting minus 1 squared minus 4ac. 4ac means 4 times a. A is 1 and c is also 1. Very good. So all over 2a, which is 2 times 1. A is 1. So simplifying further is going to give us minus times minus is plus. So I have 1 plus or minus square root of negative 1 squared gives you 1 minus 4 times 1 times 1 is going to give you 4. So all over 2 times 1 is what? 2. Very good. So now I'm going to be having x to be equal to 1 plus or minus square root of 1 minus 4 gives you minus 3. All over 2. Very good. Now, since I have negative here inside the square root, this is what I'm going to do. I'm going to multiply negative 1 by 3, which is still the same thing I have here. So divide by 2. So now x is going to be equal to 1 plus or minus the square root of 3 gives root 3, which is square root of 3. The square root of -1 is always I. Are you seeing that? Very good. All over 2. So let's separate this to get our final answer. So S is going to be equal to 1 plus or minus. Oh, we are separating. Very good. So 1 all over 2. Now take the plus first. Plus the square root of 3i all over 2. Now let's take the negative side of it. So I'm going to be saying or x is equal to 1 over 2. I'm going to be taking it to the top so I have enough space. So or x is equal to 1 over 2, which is 1 over 2, negative, which is minus the square root of 3i over 2. So we see that we have two values of s here, one value of x here, and two other values of x here. Well, if you really enjoyed this video and you have learned something from this video, please do not hesitate to give this video a thumbs up. Subscribe if you haven't subscribed. Turn on the notification bell so you don't miss my upcoming videos. And until next time, take care.